Alright, so let's review about what we have learned so far. So what is probability? Probability is something is going to happen. So something something is going to happen. Or another way you can say like how likely, because I'm using the math words. How likely something is going to happen. Alright. So right now, let's you can check out the video I've made last time. There's a vocabulary words explanation. So this time let's focus more on the formula or something. So first one, theoretical property. Theoretical probability equals number of success. So number of success outcomes over total number of possible outcomes. Total number of possible. Okay. So let's review some words from here, okay? So what is outcomes? What is outcomes? Yell it out. What is outcomes? Okay, I hope your answer could be an outcome is events that may happen. And what does events mean? What is events? What is events mean? I hope your answer is event is a set of outcomes with the same result. I think this is a pretty good to memorize to remember the formula of how to use the theoretical property formula. Alright, so right now let's focus on experiential. Experiential. I don't know how to spell this. Experiential probability. Probability. Is it right? Okay, I'm right. So what are probabilities? Experiential probability. It is in a textbook they are saying number of trials. Trials. Make sure your trial is not right as trials, okay? And over total number of trials. So well, I just put in my own words. So it is pretty simple. So in my own words, it is how much you get, or how many you get, whatever, and over how much you should get. Okay. So after review of this, let's do some problems. If you have in the textbook, it is Foundation for College Mathematics 11. So it is MBF 3C. If you can turn page to page 82, and then we can focus on some question like 1 to 5. Okay. So, well, it is compare experiential and theoretical probabilities, and then let's start it to do some questions. Okay. So the first one, if you are on your textbook, and then there should be a spinner about the rain or no rain. So first question is, consider the spinner shown. There's I think 1/4 it is rain, and then the rest of the spinner is no rain. So what that mean is, well, they put the needles in the no rain side. So I hope it's going to be no rain about this question. So here we go. Number 8. What is the theoretical probability of the spinner landing on rain? Where's the probability? Well, because as the image show us, there's only looks like 1/4 the probability will rain, so the spinner will land on a rain is 1/4. For the first one. And then the second one, let's try the B one. If the spinner lands on no rain 13 times in 15 trials, what would be the experimental probability of the day having no rain? Well, the easiest one, because remember the experimental probability is how much you get over the total number of how much you should get. See, just right up there. How much you get over how much you should get. So how much you should get? So there are 13 times, and then there are totally 15 trials. So 13 over 15. Here comes the answer. So let's try the number 2. So here's a question. You toss a coin 10 times. It turns up heads 8 times. Number 8 is, what is the experimental probability of turning up heads? What is it? So let's take a guess. Let's write down 8 times over 10, because you have 10 times you toss the coin, and then 8 times are the heads up. I think let's do some simplify of this one. So let's try if it equals to both divided by 2. So 4/5. Yeah, it's right. And then the second questions, it is, what is the theoretical probability of turning up heads? Well, it can be half-half, because the coin is always 2 sides. Always need to remember this. So heads down, heads up. half, 50% up, 50% down. That's it. So the third one, if you toss a coin several more times, would you expect the experiential probability to increase or decrease? And we need to explain it. Well, the answer back there, they're saying this is going to be decreased, but well, I've tried many times. I think it may decrease or increase. It can be both. Because like 50% up. Where's percent? 50% up or down. So can be decreased or can be increased. Is my thinking. So number three, the third one. As you see the chart on the right side, and then here's the question comes. In a bag there are 14 yellow marbles and 6 blue marbles. A marble is removed, the color is recorded, and then it is put back into the bag. This is repeated for a total of 20 times. The results are displayed on the bar graph, as the image is showing on the right. So, number 8. What is the experiential probability of drawing a yellow marble? Express your answer as a percent. Well, so 20 times, and they have tried the 17 times. So for the experiential probability is how much you get over how much you should get, right? So how much you get? 17. How much you should get? 20. Done. Number 8, done. Okay? Number B. Use the theoretical probability of showing a yellow marble. Express your answer as a percent. Okay? What is it? Well, let's focus on because the theoretical is number of success outcomes. So at first they just told us the outcome is 14. So 14 over 20, and it is 70%. Right? I forgot to this one. So after divide 17 over 20, it is 0.85, which is 85%. Okay? So we done the third one. Now we focus on the fourth one. Number 4. Question number 4. A random number generator is used to simulate the result of rolling a die 30 times. The results are shown in a table. So this table, the outcomes is 1, 2, 3, 4, 5, 6, 2, because there's die, so 6 side. Outcomes 1 to 6. Frequency, or the first outcome, the frequency he get is 4. The second outcomes, he get frequency of 6. The third outcomes, he get a frequency of 7. The fourth outcome, he get frequency of 5. The fifth outcome, he get frequency of 6. The last outcome, which is outcome number 6, he get 2 frequency. So number 8, determine the probability of each outcomes. Determine. So